Okay, so today we're going to be looking at the law of cosines in continuation of looking at oblique triangles. So just a reminder, here we have an oblique triangle. An oblique triangle is a triangle that's not a right triangle. So if we think about SOHCAHTOA, sine, cosine, tangent, those all apply to right triangles, whereas in the oblique case, we can't use that. So we have the law of sines and the law of cosines. We label triangles so that the vertices, the corners, are labeled with capital letters, and the sides are labeled with lowercase letters. And they correspond. So opposite of angle A is side A, lowercase a. Now, law of cosines, the formulas look worse, but they're actually nice in a pattern. So let's say I want to find side A. Well, the formula is a squared is equal to the sum of the square of the other two sides, so that'd be b squared plus c squared, minus 2 times the product. So 2 times b times c times the cosine of angle A. And similarly with b squared, we would have the sum of the squares of the other two sides, so a squared plus c squared, minus 2 times ac times the cosine of b. So notice a little bit of symmetry. We start with side b, we end with angle b. And then we have c squared, which would equal a squared plus b squared minus 2ab times the cosine of c. Now, if we're looking for angle A, we have to do a little bit of algebra. We have to move everything to the other side, the equal sign. So instead what we can do is we can look at these other formulas where they're already isolated. So cosine of A, and remember this is the cosine of A, this is not actually angle A. Cosine A is equal to b squared plus c squared minus a squared divided by 2bc. Then we have cosine of b is equal to a squared plus c squared minus b squared over 2ac. And the cosine of c is equal to a squared plus b squared minus c squared all over 2ab. And so I have a number of students who don't like to know these formulas, don't really care about the pattern here. So those just remember these first three. But if you just work with these first three, you have to be careful with the algebra you use. Now we have law of cosines because sometimes we can't always use law of sines. So for example, here I want to find BC. Well, that's just another name for side A. Well, if I look at law of sines, A over sine of 109, I need one of the other angles to use law of sines, and I can't. So I have to use law of sines. So I get a squared, so this is going to be a squared is equal to b squared plus c squared minus 2bc times the cosine of A. So we have a squared is equal to 30 squared plus 14 squared minus 2 times 30 times 14 times the cosine of 109. And nice thing is, we can just do a is equal to the square root of all of this. Be nice if we could do that in a notebook, right? So we're just going to use our calculators. So here I have mine handy. And so I'm just going to do the square root of 30 squared plus 14 squared minus 2 times 30 times 14 times the cosine of 109. And we get that 37.00. So if we are rounding to the nearest tenth, we would just say that this is going to be A equals 37.0. And we're dealing with centimeters. Okay, and that's it. So really straightforward, simple process of just plugging in numbers. Now, what happens? Got a little bit messed up here. Okay, so the zoom function don't work. That's fine. This got all... Okay. Technology at its finest. Okay, let's look at this second one here. So for the second problem, we need to find A. Now if you remember that formula from before, we had cosine of A is equal to B squared plus C squared minus A squared over 2BC. But the issue here is that I need to know side A, side B, and side C. And I don't have side C. So actually what I need to do first is I need to find side C. So I do C squared is equal to A squared plus B squared minus 2AB times the cosine of C. So I get C squared is equal to 20 squared plus 24 squared minus, does that say 2? Oh no, 2AB cosine of C. So minus 2 times A, which is 20, times B, which is 24, times the cosine of 82. Okay. And so we're just going to type all this in again. So remember, I'm going to do the square root because if that all solves for C squared, I want C. Plus 24 squared minus 2 times 20 times 24 times cosine of 82. And that's going to give us 29. So again, if we're rounding to the nearest tenth, we're going to say 29. So C is 29. Now I can use this formula and plug in everything. So we get, actually, I'm going to say A is equal to the inverse cosine, because if we're looking for cosine of A is equal to all this, in order to get A by itself, we need to take the inverse cosine of both sides. So this is going to be 24 squared plus C squared, which is 29 squared, minus A squared, which is 20 squared, over 2 times B, which is 24, times C, which is 29. Okay, I can plug this into my calculator. Now the nice thing about this, I'll show you a little trick here with your calculator. This button here, store, will take this exact value and store it as a variable. So I'm going to call this C, and so now every time I hit the letter C on my calculator, it's going to bring up that exact value. So that's going to reduce my rounding error. So when I plug this in my calculator, I want to make sure I have my numerator in parentheses, so 24 squared plus C squared, because that variable is saved, minus 20 squared. I'm going to close my parentheses, division sign, the denominator in parentheses. So 2 times 24 times C. Close the parentheses for the denominator, and then again close the parentheses for the inverse cosine function. And that gives us this, so 43.0 degrees. And that's going to be the most accurate answer So 43.0 degrees. Okay, simple enough. Now, word of caution, once you get the first value, you could actually use law of sines if you wanted to. However, sometimes you will give yourself the ambiguous case. So for example, if I did, if I found C, and then I used C, A, and C, or sorry, well, if I were looking for angle B, oh, sorry, no, I was right. So look at this. We have side, side, angle. That's the ambiguous case. So we need to be careful about that and not use the law of sines. So if I used the law of sines here, I would have gotten the wrong answer if I used that information. So my best advice is once you're using law of cosines, just stick with law of cosines. You won't get the wrong answer. All right, so we want to find all the angles, all the sides for each triangle. So I want to find these different ones. Now, the letters here are D, E, and F, not A, B, and C, so it's a little bit tricky. So if I want to find D, this is going to be the cosine of D is equal to E squared plus F squared minus D squared over 2EF. So remember, we do the squares of the other two sides minus the corresponding side. So this will be D is equal to the inverse cosine of 30 squared plus 17 squared minus 18 squared over 2 times 30 times 17. And so in here, we're going to yet again do the exact same thing. So inverse cosine, numerator inside parentheses, so 30 squared plus 17 squared minus 18 squared. Close parentheses, divide the denominator. So 2 times 30 times 17. Close the denominator, close the inverse cosine. And so I get about 32. So if I'm rounding to nearest tenth, 32.0. So D is 32.0. And then what we can do is we can find any angle we want. So I'll do angle E. Keep this in alphabetical order. It doesn't matter. So cosine of E is going to equal D squared plus F squared minus E squared over 2DF. So that means that E is equal to the inverse cosine of 18 squared plus 17 squared minus, that's an E, minus 30 squared over 2 times D, which is 18, times F, which is 17. Okay, and so I'm going to plug this yet again into my calculator. Now, one thing when you're plugging this into your calculator, you will get an answer. If you get an error message, it means that you did something wrong. So it's not like with the law of sines where if we get an error message, we have no triangles, it's no solution. Here, this is not the ambiguous case. That no triangle situation, no solution only applies to the ambiguous case. So we will always get an answer. So if you ever get an error message, make sure you typed or you look at what you typed into the calculator. All right, so here if we're looking at our rounding to the nearest tenth, this is 117.966. So if we're rounding to the tenth, that's actually going to become 118.0. So this is 118.0. And the nice thing is, once we have those two, we know that 180 minus 32 minus 118 is going to be equal to angle F. So that means that this adds up to 150, so F is 30 degrees. See how that works out? Not too bad. Then so for over here, for number 2, we could do all the exact same work and go through this. I think there are more problems. Yeah. Which we could go back and do, and I think that it would be beneficial for you to try it out on your own. But if you want to know what the answers are, well, it's just 118, 30, and then this side here is 18. These are the exact same triangle. So side, angle, side. Remember that from geometry? Congruent parts of, corresponding parts of congruent triangles are congruent. So same triangle. All right, now the last thing about law of cosines is the area. So area for a triangle, you probably remember, is 1/2 base times height. But what if we don't know the height? Well, we have to use trig to find out the height. It's a whole big mess. So instead, we have these two formulas to help us out. So if we're given two sides and an angle, we can do 1/2 BC times sine of A, 1/2 AB times sine of C. So notice this is all side, angle, side. And if we have side, 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 so this is side, angle, side. If we have side, 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 we can use Heron's formula. Notice Heron's formula has this additional variable s, which is the sum of all the sides divided by 2. So here, if I have sides ABC, then s is going to be equal to 6.2 plus 12 plus 8 divided by 2. So that's 26.2 divided by 2, which is 13.1. So the area is going to be equal to the square root of 13.1 times 13.1 minus 6.2 times 13.1 minus 12 times 13.1 minus 8. So the area is equal to, let's find this out. So we get the square root of 13.1 times 13.1 minus 6.2. Now if you notice, what I'm doing is I'm typing all of these in parentheses because there's no need to do this math separately. We could just type it all in one step. And there we go. So area is 22.5 inches squared. Because it's area, it's unit squared. Now here, if I'm given, this is side, angle, side, the area is going to be 1/2 AB times the sine of C. So we get 1/2 A, which is 7, times B, which is 6, times the sine of 53. So we can do 0.5 times 7 times 6 times the sine of 53. And we get the area is equal to 16.8 inches squared. And so that's it in terms of law of cosines and finding area for the triangle. So that actually sums up the entire unit. So make sure that you watch out for the ambiguous case. But if you start using law of cosines, I recommend you just stick with using law of cosines.